All right, let's talk about machine learning. I mean, it's everywhere, right? But how does it actually work? That's what we're going to break down today. Don't worry, no crazy math or jargon, just a simple, clear look at the tech that's literally changing everything. So, let's just get right to the big question, the one that kind of hangs over this whole topic. How in the world can a machine actually learn? I mean, it feels like magic, doesn't it? A bunch of code and circuits learning? Well, it's not magic, but it is a really cool and logical process.
Okay, so think about how we learn. You see an apple, maybe a few different ones, and pretty quickly your brain just gets the concept of apple. Easy, right? Well, the machine's totally different. It learns by brute force, you could say. It needs to see like 10,000 pictures of apples just to spot the patterns, the roundish shape, the stem, the color. It doesn't understand what an apple is, but man, it gets unbelievably good at recognizing the pattern of one.
And all that pattern-finding work creates something we call a model. I love this analogy. Think of it as a pattern brain for the computer. It's not a real brain, of course, but it's a huge network of connections that it's built for itself. It basically learns little rules, like, okay, pointy ears plus fur plus whiskers, that's probably a cat. That's the model at work.
So, how do we actually build one of these pattern brains? Well, it turns out there's a pretty standard recipe for it, a simple 4-step process that's used almost every single time.
And here are the steps on our roadmap. It's really straightforward. You collect data, you prepare it, you train the model, and then you test it. Collect, prepare, train, test. Let's dig into what each one of those actually means.
All right, step 1, collect. This is where it all begins. You're basically gathering the raw ingredients. So, if we want to teach a machine the difference between cats and dogs, we can't just show it a few pictures. We need thousands, maybe even tens of thousands of examples of both. The big rule here is simple. The more good data you feed it, the smarter your model is going to get.
Okay, moving on to step 2, preparation. Now this might sound boring, but here's the crazy part. See this number, 70%? That's how much of the entire time on a machine learning project can be spent just on this step. It's the grunt work, cleaning up the data, making sure all the pictures are the same size, fixing errors. It's not glamorous, but it's absolutely crucial, and it takes up the vast majority of the effort.
Step 3, train. This is the main event. This is where the magic really happens. The algorithm, you can think of it as the learning engine, just churns through all that data we prepared. It makes a prediction, like, I think that's a cat. Then it checks the answer. If it's wrong, it tweaks its internal brain a little bit and tries again. And it does this over and over and over. We're talking millions of times, getting a tiny bit better with every single guess.
And finally, step 4, test. This is like the final exam. And here's the critical part. You have to test the model with brand new data it has never ever seen before. This is how you know if it actually learned the patterns of what a cat looks like, or if it just, well, memorized the photos you showed it. If it can still get it right with new images, then congratulations, it's ready to be put to work in a real app.
Okay, so that's the 4-step recipe. But it turns out machine learning isn't just one thing. There are actually 3 main ways, or let's call them learning methods, that machines use.
First up, we have what's called supervised learning. The name says it all, really. You supervise it. Think of it like you're a teacher with a student. You give the machine a bunch of examples, but you also give it the right answers, like flashcards.
So it's literally this simple. You feed it an image, and you tell it, hey computer, this is a cat. Then you do it again, and again, thousands and thousands of times. Eventually, it starts to figure out the patterns that make something a cat all by itself. And you use this stuff every single day. That spam filter in your email? That's supervised learning. When your phone recognizes your friends and photos? Supervised learning. Even incredibly important things like systems that help doctors find tumors in medical scans? Yep, that's supervised learning too.
All right, method number 2 is unsupervised learning. So if the last one had a teacher, this time the teacher leaves the room. You just dump a massive pile of data on the computer, no labels, no right answers, and you basically say, go figure it out. Find some patterns for me. The whole idea is for it to find hidden groups or structures you didn't even know were there. The perfect example of this is in business. You can feed an algorithm thousands of customer profiles, just raw data about what they buy. The algorithm might then come back and say, hey, it looks like you've got 2 main groups here. One group is young and buys athletic gear, and another is older and mostly buys things on sale. It finds those groups all on its own, which is incredibly useful. So this is huge for things like customer segmentation, like we just said, but it's also used to find themes in huge piles of text, or for something really important, spotting fraud. Your bank uses this to see a weird pattern in your spending that doesn't fit your usual group, and it flags it as potential fraud. And our third and final method is reinforcement learning. This one is completely different. It's all about learning through trial and error. You can almost think of it like training a dog. You give it rewards for good actions and penalties for bad ones.
So picture a little robot trying to learn how to walk. Every single step it takes forward, you give it a plus point. Good job. But every time it wobbles and falls over, it gets a minus point. Bad move. Over thousands and thousands of tries, its only goal is to get the highest score possible. And the only way to do that is to learn how to walk perfectly.
This is the super powerful technique that's used to teach AI to play complex games like chess or Go and beat the best human players in the world. It's also at the heart of advanced robotics and even systems that figure out how to optimize traffic flow in a huge city. It's all about learning a strategy. Okay, so we've got our 3 learning styles, but the most important thing to realize is that this isn't just theory. This stuff is running right now all around you in your daily life. Take medicine, for example. AI can now look at an X-ray and spot a tumor, sometimes even more accurately than a human doctor can. That's a huge deal. Or think about your free time. When you open up Netflix or scroll through TikTok, what do you see? A list of things it thinks you'll like. That recommendation engine, that is pure machine learning, predicting your taste.
And of course, there's our cars. Everything from the system that keeps you in your lane to the full-blown self-driving cars of the future, it's all powered by machine learning that helps the car see and understand the road.
Now, it's not all sunshine and roses. We have to talk about the problems, too. First, bias. If you train your AI on biased data, you're going to get a biased AI. Garbage in, garbage out. Then there's the black box problem. Some models get so complex we literally don't know how they're making their decisions. And of course, there are massive concerns about data privacy and the insane amount of electricity these giant models use.
So if there's just one thing you walk away with today, let it be this idea right here. This is the core shift. With old-school programming, you wrote the rules. With machine learning, you just show the computer examples, and it figures out the rules for itself. It learns from examples. It doesn't just follow orders. And that really leaves us with the big open question, doesn't it? We've already seen it completely transform entertainment, medicine, how we drive. So what's next on the list? What area of your life do you think is going to be totally changed by this next? It's something to think about. Thanks for joining me.